Welcome back, Advanced Math. Today's mini lesson is going to be on area formulas for right triangles and parallelograms. So please label that as the next page in your notebook. And when you have done so, unpause, close it up, and think with me. So yesterday, we worked on finding the area of two different kinds of figures. One was a right triangle. Here's the exact one actually that we used yesterday to start off. To find how much space was inside of this right triangle, how many of these squares there would be if we put all these little partial ones together. Our strategy there was to take the right triangle was to double it into a rectangle. So now I have an identical right triangle here and here. Turn it into a rectangle. Find the area of the whole rectangle, which I think was 36. And then, can't see it, can you? And then say, well, if this whole rectangle has an area of 36, then my one triangle is half of that, so I'm going to divide that by 2 and get that area. And then for parallelograms, similar strategy. Kind of said, all right, well, here's a parallelogram. What I'm going to do is I'm going to turn it into a rectangle by cutting this off and moving it across and saying, oh, look, well, that's a rectangle. Rectangles are really easy to find the area of. So if this rectangle has an area of 35, it doesn't matter if I move that over here or even, up there, make some kind of weird looking figure. All the space is still there. All the inside space, all the squares are still there. So it doesn't matter if I do this or this. If this has an area of 35, then that has an area of 35. So that was our trick yesterday. So, and that's, I want to add a second strategy to finding area here today. So let's talk about right triangles. So I don't want to forget about yesterday, so we're going to talk two strategies. So yesterday's strategy is great. So strategy number 1 is double into a rectangle. Find the area and divide by 2. That's a great strategy, and I never want you to lose that strategy because formulas, which I'm going to show you today, formulas can be hard to remember, or it can be hard to keep track of what formula goes with what kind of shape. And so if you ever forget which formula to use, I want you to have this to fall back on and say, well, either way, I can still figure it out. So strategy number 2 is going to be a formula. And so formulas are, just ways to easily do it quickly for any right triangle. So what I want to do to show you where the formula for this comes from is to remember this strategy. So what we do, remember, we're going to call this the base. The side it's sitting on is called the base. And we're going to call this the height, like how tall it is. So I need to give you some numbers here. So let's just say the base here, let's use easy numbers here. Let's say it's 3. This is maybe about 8. We need a unit, don't we? Let's do inches. And then this is longer than that even. Let's just say that that's, 9 inches. All right, so what happens when we go over here, here's my base, here's my height. When we double it into a rectangle, then the area of the rectangle is the base, which is the same base as the triangle, times the height, which is the same height as the triangle. The rectangle and this right triangle, they both have a base of 3. They both have a base of 8. So what I end up doing to find the area is I multiply the base of the triangle times the height of the triangle, because that base happens to be the exact same base as the triangle and the rectangle. And same with the height. It's the same here for the rectangle and the triangle. So I just do the base times the height, and that gives me the whole rectangle. And so when I'm all done, I just take all that and divide it by 2. Base times the height, 8 times 3. So this whole thing has 24 square inches. So then to find just my triangle, I just divide 24 by 2. And that's the area. Another way you'll see that formula written is the base times the height. And instead of dividing it by 2, you often see it written as times 1/2, which is the same thing. If I multiply the base times the height, I can either multiply by 1/2 or divide by 2. So now if you know this formula, you can do this whole rectangle business without all the drawing. If you're not somebody who loves all the drawing. I, of course, am. I'm so good at drawing. I know you appreciate the opportunity to get to watch me do all this drawing. But if I just knew that this was 8 and this was 3, I would just say, okay, well, it's the area then, if I use this formula, is 8 times 3 divided by 2, which is 24 divided by 2, which is 12, which it was. Or, same here, I could do 1/2 times the base times the height. And 1/2 times 3, that's 1.5 times 8, and 1.5 times 8 is 12. So I can use, this is the formula for the area of a right triangle, base times height divided by 2, or 1/2 times the base times height. And that comes straight from this strategy. You don't even really have to memorize it. If you just remember how it works, double it, base times height, divide by 2. That all comes straight from there. All right, let's do a parallelogram one. So let me give you some numbers here. Let's say that's 15 centimeters. In a parallelogram, the parallel sides have to be the same length. So if that's 15, that's 15. And let's just say this is, looks like maybe 7. And I'm going to draw one more numbering you're going to need. If you'll remember what we're going to do here, we're going to take this and move it over there, or take this and move it over there, either way. And what we end up needing to know is how tall this parallelogram is. This doesn't tell us how tall it is. You wouldn't measure anything at an angle. We would need to know like this. How long is that? How tall is it from the base straight up to the top of the figure? Let's just say that's 3 centimeters. So strategy number 1 was cut and then turn into a rectangle. Say rec. Right? So what we did, we took this, we cut it off, and we moved it over there so that we had a rectangle. I'm going to use another color. Go blue. So I move that piece over here. I have all the exact same area, but instead of a parallelogram, now I have a rectangle that is 3 by 15. So now I can look at this and say, well, the area here is 15, which is the base, times 3, which is the height. And so actually the area for a parallelogram is the exact same for a rectangle. It's just base times the height. This had a base of 15 here, and it has a height of 3. Remember, this is going to be a 3, not a 7. The 7 doesn't end up mattering, actually. So like if I go back to my original thing, check it out, so you kind of know where it came from. Just erase everything here. So this originally, we would call this the base, the side that it's sitting on. That was 15. And then the height was 3. So what I'm saying is the area of the parallelogram, if I don't even bother to turn it into a rectangle, because that's not going to change the area, it's still the base of 15 times the height of 3 to get 45 square centimeters. Because all that I'm going to do is turn this into a rectangle, and that rectangle still has a base of 15 and a height of 3. So I don't actually get to use the exact same formula for a rectangle that I get to use for a parallelogram. Same formula. I don't even have to divide or do anything. I can just look at it and mentally say what's going to be the same. All right, let's do 2 in your notebook. So here is a right triangle. So remember, go ahead and write down strat number 1 here. strat number 1 is double into a rectangle. Find the area and divide by 2. Right, so we would take, let's just say this is 2 inches and this is 18 inches. So what we do is just double this thing into a rectangle. Do this base times this height, and divide it by 2. So our formula, strat number 2 is going to be a formula. So all we do is we just don't bother doing that on the drawing, and we just kind of do it in our head and say, well, the area is going to be this base of 18 times this height of 2. And base times height gives me the area of the whole rectangle. And so after that, I just have to divide all that by 2. Or I can say the area is, you'll often see it written as 1/2 times the base times the height. Either one is totally fine. All right, so this is just a way to do with math what we do here. Double it, find the area, divide by 2, or just find the area of the rectangle, which is the double, base times height, and then divide that by 2, or multiply that by 1/2, either way. So that's the second strategy for a right triangle, if you don't want to do the cutting and the doubling. And let's do a parallelogram as well. So sometimes they often get drawn this way, and I don't want it to confuse you, because what I can do is, you can draw it the other way, but just to think about, if it's not sitting on its base, which this one's not, it doesn't change the area to reorient it. So if you want to imagine turning it, if it starts like that, you can. So now when I look at this is the base. Let's just say that is 3 miles. And this is a confusing part. This is nothing. Let's say that's 2.5 miles. That is not the height. That's the side of the parallelogram, but it is not the height. The height goes from the base straight up to the top, like that. And that's going to be a little shorter than this, so let's just say that's 2 miles. All right. So here, our first strategy was just to cut and move to make a rectangle. Right, and our strat 2 is going to be a nice easy formula. So what I end up doing is I would take this piece and move it over there, and if I do, and now it's not here anymore, now I have a rectangle. And if you notice, you get really lucky here, because the base of this rectangle is the same as the base of the parallelogram. It's 3. And the base of, or the height of the rectangle is the same as the height of the parallelogram. The height of the rectangle is 2, and the height of the parallelogram was 2. So the formula for a parallelogram is same as it is for a rectangle, because it's base times height now. So if I were to just go back to my original thing, this rectangle had base 3, height 2. Well, this parallelogram, guess what it had? It also had base 3 and height 2. It doesn't make any difference if I view it as a rectangle or a parallelogram. And the other little thing to remember, this 2.5, this didn't matter. I mean, it would matter if we were finding the perimeter and going around the outside, but it doesn't matter for the area. We just need the base and we just need the height, and that's it. So it has the same formula, as long as you remember what's the base and what's the height, has the same formula as a rectangle. All right, tricky stuff. I hope this seems okay to you. If it doesn't, please go back and watch some of these examples again to make sure that you're really getting a handle on this. This is very different from a lot of the math we normally do. So if you need to go back and watch again, please do. Otherwise, when you got your notes finished, you're all set.